Okay, so we are live. Okay, so guys, our today's Leetcode's POTD is minimum number of steps to make two strings in anagram. So let me explain to you guys. So an anagram is basically two strings that contain same number of characters with the same frequency. For example, we have been given a string anagram and another string nagram, which are having same number of characters with same number of frequency, so they both are anagrams. Same is with the case rat and car. We have same number of characters with same number of frequency, so these two are also the anagrams. And in the example and in the question we need to check that how can we convert both the strings into an anagram by replacing some of the characters from s with some of the characters in the variable t. For example, we have been given two strings, one is Paul and one is ABA, which are having, like in S we have B counts to 2 and A counts to 1, and in T we have A counts to 2 and B counts to 1. So what we can do is we can just simply transfer 1B from S to T and 1A from T to S, which is basically we are replacing B with A, which is equal to 1 conversion. So it will only require one conversion to make both the strings in as an anagram. So how we can approach this question is, first of all we can just simply initialize our vector array with 0 of 26 length to store the frequency of characters of both the array. So what we are doing here is we are just first of all storing the frequency of s in our array arr, and if we found same character in our string t, then we're decrementing it and we're just initializing one variable result equal to 0, and in the result we are just simply incrementing the difference of both the difference in characters that are not common in both of them in our result, and we are simply dividing it by 2 because we are replacing two characters which are like two different operations, but we are swapping them, by which we are getting two operations in a one time. So we are dividing it by 2 and then simply returning our answer. So let's try running this code. Okay, let's try submitting it. Okay, so as you can see guys, it got submitted. So this was all for our Leetcode's POTD. So now over to you, Sanam.
So guys, the question that we have been asked in GFG PODT is that there is a linked list that is given to us, and we have to apply the insertion sort on this linked list in order to make this whole linked list as sorted one. So it basically just means that by the means of insertion sort, we have to sort this link linked list. Now, before we go in depth about how we are going to apply the insertion sort, let's just first understand that what is insertion sort. Let's just say that this is our given array that is provided to us. Okay, and as you can see, it is in descending order, and we have to rearrange the element in 3, 4, 5 form. So what we are going to do, we are going to take two variables. First one will be I, other one would be j. Initially the value of I would be this one, and the value of j would always be one less than the value of I. So let's say if the value of I is 0, the value of j would be minus 1, 1 less than, okay. And in this case, we are going to compare the values of I and j. And if I'm finding a value that is that the value of I is greater than the value of j, then I'm going to simply replace the value of I with the value of j. Now let's just understand it, okay. It would be quite heavy, single dose. Let's just understand, okay. So as you can see, in the first instance, when I is 0 and j is minus 1, there is no value with minus 1 as its index, so we can't do any kind of comparison here. What we are going to do here, we're going to simply move forward. So now our I will become 1 and our j will become what, 0. Now here the key part. Here we're going to compare the value of j with the value of I. And as you can see, the value of I is actually smaller than the value of j. What does it mean? It means that the previous element, this is our string, that the previous element is greater than the next element, and it should not be possible in a ascending order list. Why so? Because in a sorted list it would be something like this, that the previous element would always be smaller than the next one. But in this case, we are getting that our previous element is actually greater than the next element. We can't deal with this situation. So what we are going to do, we are going to do arrangement such that our array would look something like this, and we are going to store the value for in some sort of array, okay, some sort of key. So let's say key is the variable in which we are storing the value of our 4. So now let's just see that what we have done till now. Just understand it. Initially the value of I was 0 and the initially of the jth values was minus 1. We can't do any kind of comparison here, so we are simply moving forward. Now the value of I is incremented, and as well as the value of j is also incremented. So now the value of I is 1 and the value of g is 0. So that is I is this one. So our I is this one and our j is this one. Then we are here comparing that if the previous value, if the first index value is actually greater than the second index value, that cannot be possible in a sorted array. Why so? Because in a sorted array, the value that comes previous than the next value would always be smaller. As you can see, it is smaller. 1 3, this is a sorted one, it is smaller. 0 5, this you can see, this is a sorted one, this is smaller. But in this case, it is not happening. So what we are going to do, we are going to make certain kind of arrangement, as a result of which our array would look something like this, okay. And after we made this arrangement, we are going to, what do, we are going to decrement the value of j. So as a result of which, now initially if j was at this index, now it will go to its previous value. So it means that it will come to the index minus 1. And as we all know that the index minus 1 does not exist, so we are going to come out of the loop and we are going to rearrange our array. It would look something like this: 4 5 and 3, just simply replacing the value of this value with the value of k. Then as I was in here, what, 1. Now we have to move forward, so now our I will become what, it will become 2, and our j would always be one value less than I, so it will be 1. So our array is right now 5 4 5 and 3. So now as you can see, in this case, this is I and this is j. 5 is actually greater than 3, which cannot be possible in a sorted array. So what is going to happen, by the help of our condition, it will look something like this. What would look the array, okay. Then after that, the value of j would be decremented. So as a result of which, now we are going to compare the value of 4 with the value of 3. So as you can see, it would look something like this. And we cannot deal with this situation. Why so? Because the element that is coming previous to the current one should always be smaller in a sorted array. So we are going to do, we are going to make some kind of arrangement, as a result of which our array would look something like this. And after that, as my j would reach to minus 1th index, which does not exist, our array would look something like this by replacing the value of this with 3. That is what insertion sort is about. So basic idea is, if I am at a current particular index and I have a certain value, and there are, let's say, 10 elements previous to this, I'm going to compare with each of the element to this value, and whatever value that I found for which my given value, let's say it is 1, given value is actually smaller than this value, I'm going to change or going to push that thing here. That is what insertion sort is about. If I'm index 0, I'm going to compare it with the lesser value. If I'm index 2, I'm going to compare it with the values that are previous to me. If I'm index 3, I'm going to compare it with the values that are previous to me. That is what insertion sort is about. Now the same logic is what we are going to apply in linked list. One way to do this problem is that push all the elements of the linked list in a vector. Either you can apply simply the sort function, but in this case we have to apply the insertion sort, so we can apply insertion sort here, and then again create a linked list, and that would be our answer. But the key part or the trick part is to do it inside the linked list and not to create outside, or not create any other data structure to solve this problem. So how can we do inside linked list? That is the key part that we have to understand. So now let's just see how we are going to do. Let's just consider this is our list. Okay, so these are our list elements, and they are connected via their links and thing. First thing that we are going to do, we are going to create a dummy list. What does this mean? We are just going to say, what, this is my initial list which have certain kind of value, and it would be somewhere like this. Okay, and this one is going to be called as temp. Now I'm going to move forward from this dummy list, and I am going to compare the value of it to the other values. Initially there are no values, so I'm going to simply pick this value here, and I'm going to push this value in this. So as a result of which my linked list or new linked list would look something like this. Now we are at in this index. Okay, and now our process will move forward. So initially we will start from dummy, and we are going to compare that if the next element of dummy is smaller than the value of this index, and as you can see, -1 is actually smaller than 5, so we are simply going to move forward. So our temp would now move somewhere like this. Now again I'm going to check that if that value that is next to the temp, and as you can see in here it is null, so we can't compare any value, so we are going to simply move out and push the value of 5 ahead of our this value. So this is my newly formed linked list that I have created. Initially it was 0, now it is, this was is dummy, then our -1, and then our 5, and this linked list that is available to us now is 3, 4, and 0, and these are the elements on which we have to do the traversal again. Okay, so now again I will be a dummy, and I'm going to compare that if the value that is next to this one is smaller than 3, and as you can see -1 is smaller than 3, so we are going to simply move forward. Now our temp would be here, and I'm going to compare this value. So I'm going to see here that 5 is actually not smaller than 3. No sir, it is not. So what I'm going to do here is I'm going to say that -1's next should be 3, and then 3's next should be 5. So the result of which our list would look something like this now. This is our D, this is our -1, and this is our 3. Then comes the next element. What would it be? It would be 5, because that was already present. And in our linked list we are only left with 4 and 0. Then I'm going to be at dummy. I'm going to be at dummy, guys. Just again, for every traversal, every element that we are including, we're going to come back to our dummy and to compare with each element to this value. Again, I'm going to be here, and I'm going to say that, what, hey, -1 is greater than 4. So -1 is actually smaller than 4. So we are simply going to move forward. Then we are going to compare the value of 3. As you can see, 3 is smaller than 4. So we are simply going to move forward. Now we reach 5. As you can see, 5 is actually not smaller than 4. No, it is not. So what we are going to do here is we are going to remove this connection that we have created. We don't want it because it is causing us these errors, and that would not be good. So what I'm going to do, I'm going to say that, connect this 3 to this 4, and connect this 4 to this 5, as a result of which our list would look something like this. This is our D, this is our -1, this is our 3, this is our 4, and this is our 5, and the one that we are left with is only 0. Then again we are going to compare now. Again we will be a dummy and then we're going to compare. So minus 1 is actually smaller than 0. Yes, it is. But if you see 3, it is actually not smaller than 0. No, it is not. So what we are going to do, guys, you all know, we are going to break this connection. We are going to connect minus 1 to 0 and we are going to connect 0 to 3. So ultimately our list would look something like this. This would be our dummy, this would be our minus 1, this would be our 0, and then all the elements that are available there. So 3, 4 and 5. So this is the way that we are going to get our thing. Same logic had been applied as of insertion sort. As you can see in insertion sort, if I am at fifth index, I am going to compare with every value that is available behind it. So I am going to compare this value with 4, compare going to this value with 3, compare it with 2, compare it with 1, and whatever value that I found which is smaller than this value, I'm going to, you know, just let them be, and the value that I'm finding greater than this value, I'm going to replace this value from here. The same thing that we have applied in this logic for this link list. Now let's just see how the code would look like. So first of all, we are going to create a dummy list that we have done in this case. Then we are going to move ahead our list. Of which list? This is the one that we are talking about, this one, which was initially that we have taken this one. Till we reach this value, we are going to simply run over the operations. Okay, then the next thing is we are creating a variable name temp which will point toward dummy. We are creating a new pointer which is next, which will be the next value of the value with which we are comparing our value of temp. Then in our this function or this loop, we are just, you know what, saying that if the value, this is the thing that we are doing, that if the value is smaller than, just simply move forward. That is what we are doing with this loop. And once we find a value which is actually not smaller than the head value, we are going to do this operation. This operation that I have told you of connecting the link is what is happening in here. And after that, after we have done all the iteration of it, we are going to simply return dummy as dummy is next as our answer. And as you see, if we just submit this code out, it would work perfectly fine. So guys, with that, today we have solved both the GFG and Leetcode POTD. We hope that you guys be able to understand it and now will be able to solve this problem on your own. With that, over to you, Shivam.
So yeah guys, thanks for joining with us. We will catch you up tomorrow. Okay guys.